Drosera operator binary CLI that will allow you to run an operator. Okay, now I'm going to run bun install, and I believe this is, John, I believe this is just like an npm alternative, similar to running npm install.
Yeah, it's an alternative to using Node. It's a little bit faster, so if you do have a lot of dependencies, it will install those dependencies a lot quicker. So we also recommend to install bun, use that instead of Node.
Okay, great. All right, so now we have our dependencies installed. So we're going to run our make command. We set up a make file here. This kind of makes running through this stuff easier. So let's take a look at our make file. So we're going to run make build workshop 1, and this just goes down into the individual directories and is going to build the Solidity for you. So you don't have to worry about this too much. We can simply run this, and this will compile our Solidity code for us, our trap code. Make build workshop 1. Great, okay, we compiled 25 files. Warning here that we don't need to worry about. And now let's go take a look. We just compiled this code. Let's go take a look at this trap so we see what's going on here. So inside workshop 1, we go down into source, and we'll go into our trap here, Trap.sol. Okay, so every trap has a collect function and a should respond function. And when I mentioned in the Drosera.toml file about the block sample size, that controls how many times when an operator is actively running this trap, it will run this collect function over block sample size number of blocks. So right now it's set as 1. So for each block, it will just run this collect function for the current block. And what that's going to do is it's going to go to our hard-coded response contract. And we're going to call a function on that response contract called isActive to see if it's active or not. That's simply a Boolean value. So we're going to encode that and return that. We're returning some bytes here in memory. And so once all the collects are done, in this case it's only 1, the operator will call should respond and pass all of the collect data into here as an array. So we only had 1 collect, so we're just going to check the 0th index of the data we pass in. We're going to decode that as a Boolean, which is this active. Is it active or not? So if the contract isn't active, then we're going to return false with no data. But if it is active, we're going to return true, okay, with no data. So that's essentially how the trap works. Every block, it's going to check if this contract is active, and if it isn't, it returns false, and if it is, it will return true, which will then trigger the trap and call our respond function on this contract. And these contracts are already deployed on Husky testnet, so they're good to go for you running this, that when the trap gets triggered, which we'll get to, that this will actually be there to be called. Okay, now let's go down to the next README. Let's go into the actual workshop 1 README here. So what we're actually going to do in this workshop, we're going to run basic commands to deploy a trap. Specifically the Drosera apply command. So we'll get there in a second. So make sure to build the contracts before running the Drosera command so the updated bytecode is used. We haven't updated the trap at all, so it's fine, and we already ran the make build workshop 1, which you can see changed directories down into workshop 1, and it ran forge build for us. So we're already good on this step. So now we're going to run the Drosera dry run command, and this essentially allows us to test like a local ad hoc execution of the trap. It's like spinning up an operator in the blink of an eye on your local computer to test like 1 block's worth, 1 cycle of trap execution. So assuming your code compiles, your trap compiles, there's no trap compilation errors, but your trap, it could have some sort of runtime error. So this actually pulls real state data from wherever your ETH RPC is pointed at. So Haleski in this point, it'll pull real data from Haleski, but test it locally just one time to make sure that the trap can execute one cycle with no problems. So let's go ahead and run that. Okay, great. You saw a loading bar for a second there. It was collecting blocks. So if I have it set to 10, you'll see the loading bar go for a while as it hits the RPC to collect each block. And that one was quick because it's only one. And you can see, again, mapping my trap here with the arbitrary name I have set here. So that's how you can correlate these together. And so it ran this trap one time locally, ad hoc, and we can see that should respond was true, which from reading and understanding our trap means that our response contract is active. And so that ran it over this specific block, 3,910,098, and it returned no data. And I've also seen some people in Discord ask why this is 0. This trap address is 0. Well, right now it's 0 because we have not deployed this trap at all. So it's just basically a placeholder value. But once we actually deploy this contract, if we run dry run again, we'll actually see the trap config's on-chain address here. So this is all great. Also, I'd just like to clarify, people ask is should respond true or false, is it good or bad? It just depends on the context. Everything here is working fine. It returned a result, which is good. And it entirely depends on the context of your trap if, something is good or bad. So everything here is great. All right. Now we're actually going to apply this trap to the network. So we're going to run Drosera apply. First, I just want to demonstrate one other command, the Drosera plan command. And this just figures out, is this a new trap? Is it an existing trap? Are we updating? And when I run the apply command after this, that is essentially like bundling the dry run command and the plan command together, and then it will actually give you the choice if you want to deploy it or not. So if you're not actually ready to deploy, okay, here we go. Invalid number of operators. Deploy or plan against invalid number of operators.
You need to put it in the whitelist.
Yes,
array.
okay. I thought I might run into this error. So if you run into this error, which if you're following along, you will run into this error, and that's because I have private trap set to true, but I didn't give it any whitelisted operators. So what I'm going to do here is I am going to copy my address, and I'm going to put my address in here. Okay. So now I will be, when I run my operator with using the key for this address, I'll be the only operator that's allowed to run this trap. Okay. So let's give this a shot again. Drosera plan. Fantastic. Okay, so we can see what our plan is going to be. Nothing actually happened. This is just showing what will happen if we run the apply command. And this is going to create a trap for my trap, again, that word, gas estimate, and the really crucial configuration in here of the response contract and function. And I'm on the whitelist here now. Okay, so let's run Drosera apply now. Okay, collected block. So it did its dry run. Everything is it's working. This is good output. Then we see our plan. This is a brand new trap, so it's going to be created for the first time. Okay, now do I want to apply these changes? We don't do yes here. We do of course. Okay, and apparently I don't have gas. I swear I send gas money here.
You just need a little bit more. That's what it looks like.
Yeah, I guess let me my address in the chat real quick.
Gas.
Send gas, please.
Send gas. Okay, we'll send you some. I got 2 ETH on the way
Oh,
to your
wow,
address.
big bags.
That's right.
I've been sending like 0.02 and stuff. I'll give this a shot again.
It's still pending.
Okay. Still pending?
Yeah, let me go ahead and use a different account.
Okay.
Husky's had some volatile gas
Yeah.
prices lately.
Take some questions in here. Somebody said, can the response from the trap be executed in the same block in which the trap was triggered? And the answer is no. So it will be at least one block after something was being done. So in that case, if you found something, that get function to send back to the should respond, it'll be at least the next block for it to actually do something. So in this case, this is why having any type of same block loans or same block exploits are very hard to stop, just because we cannot respond within the same block to stop any type of flash loans or anything like that.
Yeah, the trap is basing all of its decisions on the data it gets from calling collect. And so this is calling collect on the latest available block data, so it has to be already codified in state, not stuff that's just like in the mempool or anything like that. It's all, once the block is completed, then the collect can pull the new updated state and then respond. So the next block.
Gas should be on the way pretty soon.
Okay. Yeah, I don't know if mine just didn't send earlier or what.
Yeah, I've seen Husky has had a lot of activity recently, and so usually if you're using MetaMask, it just means that you have to choose like aggressive gas pricing. It's like one of the advanced options in MetaMask. I've seen it kind of like fluctuate all the way from 0.2 base fee of Gwei all the way up to like 180 or so. And so, yeah, sometimes just using something like MetaMask for testnet, especially for Husky, you got to give it a little bit more gas to work with. Right now, I have a transaction that's pending. It looks like the transaction hash itself is confirmed, but it's still making its way over there. John, you might as well try as well if you can. Send him some gas in case my transaction takes too long.
Yeah.
Well, let me just. Yeah, I'm double checking. Sorry, guys, I'm just double checking. 100% I'm sending the right address. Yep, that's it. Here are my dummy test accounts here. Technical difficulties.
Yep. Yeah, having to it's one of the things to keep in mind if you're doing any of this, any trap deployment. Obviously, you have to have some Husky ETH in order to go and deploy a trap. There's like a couple different faucets out there. I've got plenty of Husky ETH. Usually don't use what. John, do you know like a Husky faucet
Yeah,
that
you can use
people typically use?
you can use the proof of work faucet, which is very easy to obtain a decent amount of ETH. If you just search Husky proof of work, this is what I've used in the past for many deployments where I needed a ton, and you just sit there for about 5 minutes. No, I don't think it's Google. I think it's the one right below that.
Okay, from Germany.
Yeah, that's the one.
Okay. Should be just copy from right here.
I, for some reason, can't even send you ETH.
Yeah, I think the Husky gas prices shot up really high. Must be at the same time that we started this, so.
Okay. Should I stop mining and claim rewards? I think that looks good. Oh, 0.5. Yeah, let's go.
It does. I don't know how long it's going to take you because the network is also slow. Yeah, I can't even send you any. It won't even let me continue.
Well, I can try to switch over to my last key pair. I already deployed the stuff. Let me try this one more time. Drosera apply. Oh! Thank God. Okay, I think we're in business. Alright, we're so back. Okay. So, here's my transaction. Husky link. Let's see, this should... Oh, it's gonna go open in Firefox. Okay. Yeah. So, success on Husky. So, we successfully deployed my trap, whatever name you want to give it here, how much gas we used. And here's the address that the on-chain trap config is deployed at. And I want to make the connection here that what you see here, now it has updated our Drosera.toml file for this trap. And we see a new line 17 here that didn't exist before. If I look for it, yep, they're the same between the two. So, to be really clear, when you deploy a trap for the first time, a trap that has never been deployed, it does not have an address. But when you run Drosera apply and you deploy that trap, you create it for the first time, it will automatically add the trap's address to your Drosera.toml file per trap. So you could have multiple traps. I could have another one down here, my trap 2, my trap 3, and these all have individual unique addresses. So now our trap is live. Well, I use live in air quotes because what I need to demonstrate now is that even though I deployed the trap, it's not technically running yet. So we need two things. We need a trap that's deployed on chain, and the bytecode was sent to one of our seed nodes. And two, we need operators, or at least min number of operators running the trap that have opted into it for our trap to actually be executing. So let's take a look. Let's go back to the workshop here. And so what we're going to do is we'll know our trap is working once it has been triggered, and it'll be triggered and it will call this respond function, because we saw in the trap here this is set to is active, so it should be returning true basically every block. So it should call a respond function, and in this response contract it keeps track of who has responded. So I should be able to query it and see my address is actually there. So you can take this cast call command here in the README. This is the address of the response contract, and then you just need to add the address of the account you used to deploy the trap here. So I have my command already created down here. Okay. So let's try this. Okay. And I added this bool here at the end that's not in the README. If you don't have this, all zeros means false. So it doesn't have my address recorded yet, and that's because, as I said, the trap's not actually running yet because there's no operator running it. So let's move to the next step here. So now we're going to spin up our own operator, okay? So the very first thing, again with these make commands, so there's actually a little bit more under the hood here. You can go into the make file and understand the actual Drosera operator command under the hood and the arguments that come with it. But for now, I can just run this command easily. And I have my environment variable set up in an environment variable file. You can look some more into that.
One quick note, I know there are probably a lot of people that are using Windows. Make commands and make files, I don't believe work on Windows machines. So if that's the case, just go into that make file and then just copy and paste the actual command that's in that make file.
Right, okay, yeah, so you can just come in here under register operator, copy this, and you can fill out these individual, put your RPC URL, and you can basically copy all of these that you had set here in your Drosera.toml file. Okay, so I'm going to register my operator, and this is essentially registering the key pair that I'm using for the operator into like the Drosera protocol on chain. Registering my operator's BLS public key into registry. Great. Okay, so my operator is registered now. If you don't do this step first, none of your operator commands are going to work. You're going to get errors because you're not registered. So please register first. Okay. Now I'm going to opt in, and this is where I tell my operator, hey, I want to run this trap. Okay? And if you haven't whitelisted your operator on a trap, then this won't work because you're not allowed to. So if you're whitelisted, then you will be able to opt in. All right. Okay, now I do remember opt in here in the make file. These are parameterized, but my trap config address, you need to come set this in here, okay? Your trap config will never be all zeros. This is just a placeholder value. So where do I go to get that? I go back to my Drosera.toml, and since my trap is deployed, it added the address here. So I can just copy the address, come back here, replace this. Okay, save that. Now we will copy this command, make opt-in. Okay, so now I'm gonna opt my operator in. Opting into trap, 1F89, 1F89, 1F89. Okay, opt-in transaction successful. So on chain, my operator is opted in, but I'm not actually running it yet. So that's our last command here, is to actually run the operator. So I'm going to go over to a different tab here to run my operator, because this will stay running. So make run operator to start the operator. And we are going. Okay, let's give it a second. And we can see at the top here, number of opted in traps 1. If I started this operator before I ran the opt-in command, this would say 0, and the operator wouldn't be doing anything. It's not signed up to do any work, but we have one trap, so it's going to be consistently running this trap and generating attestations. So let's see, here we go. I can see it ran successfully and it got a should respond equals true. Okay, and then it keeps running, should respond true.
Yeah, and you can actually see there's a log that says
here we go.
the pending transaction. Yep.
Okay, this is what I was looking for. So it successfully submitted a claim, and this is it got a true. It got should respond equals true, so that means it's going to attempt to go call this function on this contract. It's going to respond, and it will also continue to keep trying to do this. It worked the first, not going to anymore until I believe 33 blocks. Yeah, cooldown period blocks. 33 blocks before it allow it to trigger again. So we have our 1 here. So now I should be able to come back and run my cast call again to check and see if I have responded. And there we go. True. So that's a Drosera trap in action. I didn't do anything. I just deployed my trap. There was an operator that was running my trap. It analyzed the chain state per block, and it saw that the conditions were true and should respond, and so it responded automatically, and on-chain changes have taken place, and we went from false to true. So I think it's pretty much as simple as that to get started with deploying a trap. So this is a basic example, but you can make this as advanced and complicated, etc., as you want for any sort of on-chain use case that you can imagine. And I think that pretty much covers it for Workshop 1. And I guess we can turn it over to questions at this point, or if anyone is stuck along the way trying to follow along.
Yeah, I'm curious how many people actually ran through at the same time and got it working.
Which RPC do you recommend? I've had great success with Alchemy. They're actually one of our whitelisted node operators as well, so we love to support them. You can just make an account and create a Haleski Ethereum RPC for free. It doesn't cost any money, and it's significantly better than just like the open public node RPCs that you can use. So definitely recommend Alchemy.
Yeah. I usually using one of the RPC services is always going to be your best shot. The public RPCs aren't really meant for running infrastructure. They're kind of like better for like little one-off little things. You need to go do a little transaction or send something. But the Drosera operator, when it spins up, it's going to do a lot of different calls because it's running that trap, right? So it's going to do all of the data collection that trap defines for the operator to do. And that's usually why you'll run into like error 429s, which is a rate limiting error if you're using a public RPC. So yeah, Alchemy is usually the way to go.
Can we bring Johnny Boy on the stage? He's got a long question. Johnny Boy, hello.
Hello. So I'm not a technical person, so my question might be not fully correct. But I have previously asked you about if it's possible to send the reply from the trap in the same block, and you said no. So I decided to Google it a bit, and I found that so according to the internet, it's possible, but just I wanted to ask if it's really possible because I'm not deaf and just interested. Yeah, it's also using off-chain monitoring and flashbots. Like the system checks the mempool online.
The using the mempool, the only kind of trick there is that you're using transaction information that hasn't been confirmed yet. It's kind of like seeing a pending transaction. And what we do is, rather than like looking at a particular transaction that is happening in order to try and like perform some action, we actually look at verifiable state. So anything that is like cryptographically verifiable about the state of Ethereum, we action on that. And in order to take an action on something in a verifiable way, you have to be able to prove that the state was that way a block ago, or 2 blocks ago, or 3 blocks ago. So for us, we need to make sure that the system is completely mathematically provable. So we need to make sure that state exists at least a block ago. This really helps to make sure you don't get like false positives. You don't have the system going and taking an action when it shouldn't be. A really good example of that would be like, if you see state change, or you see a transaction maybe in a pending pool, and a reorg happens, right? And in that case, it would be really bad, because you would have the system take an action that in reality should never have happened, because history rewrote itself. Let's say you had like 1 block reorg where the chain actually forked to a different state, or the chain forked 2 blocks or 3 blocks or 4 blocks, right? So in order to make sure that there's no false positives, we always use state that's effectively been confirmed. And so that's why we have the system set up this way. It's all just to make sure that there's additional security and verifiability on top of this. So yeah, it's a good question. That is how like some of these systems have worked in the past, right? Is that they try to look at a mempool and they try to take an action, and certainly that may allow for you to front run something. However, you're not always going to be able to front run a transaction because people may use a private mempool, right? If they use a private mempool, then there's actually no way for you to see that a transaction is even going to happen in the first place. So there are like pros and cons to both designs, but with Drosera specifically as kind of this like general purpose automation system, we have to make sure the whole system is mathematically verifiable and safe. No false positives.
I think that kind of fits into one of the recent questions. How does this prevent false trap triggers? That we're not reading, we're not pulling any data from like mempool stuff that can change. So you could have like a false trap trigger. It's all like concrete, already in state. Consensus has been made on it, and so there shouldn't really be any false trap triggers.
Yep. Yeah, exactly. Thanks for the question, Johnny. There's a couple other really good questions in here. Yeah, we kind of already covered that. The prevent false trap triggers. Anything else in here that is like particularly good question for this?
I mean, it's this one asking about the red blocks. So if you're running, you deployed your trap, you're running an operator locally, the operator is going to be difficult to actually get those red blocks because you're running it locally. So that's if this is what you're doing currently and you're getting red blocks, that might be the reason.
Yeah, if you're running the operator locally, especially for any kind of testing here, don't worry about the red blocks. The red blocks are really like liveness data. It's the ability to get liveness data from your operator and show it through the front end. So if you wanted to show green blocks, you have to follow some of the guides that we've put in place and other people have put in place, where you're making that operator like open to the network and reachable from the internet. If you're doing testing, just like for this workshop, you don't need to worry about it. It's not going to have any like real kind of effect when you're the only operator running your trap and you're really just trying to test out how to trigger a trap, etc. If you want to get green blocks, yeah, you'll have to look at some of the guides that show you like opening ports or using like a VPS that has some of the ports configured in a way for you to actually have it reachable from the open internet. It's just a little bit more advanced. And again, you don't need to necessarily worry about it. When we do testing ourselves, as the Drosera team, we'll spin up an operator locally and we don't worry at all about the liveness data. The only time that we worry about the liveness data is if we're trying to run like multiple operators under a trap, and we make sure that they're able to talk to each other and we're able to see like a status from the front end. That would really be the only time you would care about it.
Yeah, there's another good question. What steps are involved in testing and verifying the functionality of a deployed trap? Well, before you even do that, like I said yesterday, definitely write solidity tests and just mock out what a operator would be doing. And you can see examples of this in our examples repo of what we have made tests without even needing to run operators. We can test our traps. So if you're testing your traps offline in your test suite, you'll know for a fact that they're going to be doing the same thing once you deploy an operator. So highly recommend write solidity tests for your traps, just like any other smart contract, and then just mock out, and you can see how we've mocked out what the theoretical operator would have done if it is true or false. Write those tests, and then you'll know ahead of time if your trap is going to be working in the real world, because you can fork all of these tests as well. And in those examples, we forked mainnet, so we could see theoretically how traps could have worked on mainnet. Even though we're not on mainnet, you could see theoretically how they would have picked up certain exploits. So write tests. If you haven't used Foundry, absolutely use Foundry. You'll thank us later for doing it because it makes all of this so much easier, but definitely write solidity tests for your traps after you make your traps.
Yep. If you know Forge, if you learn Forge and Foundry, and that leads you to learn a bit about Solidity, you really should be good to go for understanding how to make traps. All you really need to know after knowing Forge and Solidity is the Drosera CLI. So we have lots of dev docs that show how to do all this stuff as well. Also this video, we're recording this on YouTube, and we have quite a few other videos that walk through how to do this as well, and the different aspects of Drosera. So those may help you to figure out how to run this stuff, how to run some of these commands. They're pretty simple. Once you get a handle on Forge, though, I would say you're already cooking. You should be able to do at least like Solidity Smart Contract 101 stuff. And at that point, I mean, you're working with like the best tools in the space for Solidity development. It's a lot simpler than you think. You really the really like advanced Solidity stuff is where you probably need more experience. But for the Solidity 101 stuff, there's like lots of tutorials out there, and really simple tutorials that are like 30 minutes long that may help you understand smart contracts at a more granular basis. But for this workshop, we've already built a lot of the stuff out for you, so you shouldn't need to worry too much about exactly what is all happening. As long as you follow the steps that we've kind of like laid out here, you should be good to go.
Yeah, the other question, does this mean that even when it's red, my trap is still running? So yes, if you're getting red blocks, that does not mean your trap is not running. It is still running. It just we can't access, so say you're running it locally, it cannot access your local computer in that way to find out what it's doing. So just because you're getting red blocks, that does not mean it's a bad thing. It just means that your operator is not connected to the real world to be able to get that data out there. So it's still running. It just means it can't access the liveness data. So yeah, that's correct. And then the other question is, where exactly is the actual trap logic stored off chain? So when you do that apply, it's taking and compiling your bytecode of your trap contract. So it's taking that bytecode and then passing it to seed node. Seed node is using it, and then the operators are the only ones that have access to that bytecode.
How does Drosera make sure the network stays truly decentralized when it comes to trap execution, especially as more operators join and opt into different traps? Well, you can almost think of Drosera and like each trap is like its own mini consensus world. There's not some like global Drosera consensus, it's like per trap. And so there's a couple different ways you can go about it. One way, like we just did, is I deploy my trap and I'm running the operator that's running my trap. And so I like have full control of like the whole stack essentially. Alternatively, if I didn't want to run an operator, I could, delegate, or I could whitelist a number of other like say 15 other operators to run it. And so I don't know, and maybe I don't know any of those people. They're just random operators out in the world. But by setting the minimum number of operators required, as you saw in the Drosera.toml file, the higher I set that minimum number of operators in order for the trap to come to consensus, to be able to execute, the higher that number I set, it gives it like a bigger, it's like having a bigger validator set essentially. So you kind of have your own, you can configure that aspect yourself.
Yeah.
And then Boba can also touch on some of the ZK like backup stuff.
Yeah, I think like the thing to understand is that you're kind of in control of your trap. Like it's your infrastructure if you're the one who created this trap, right? So you get to decide what to do with it. If you want to run the operator yourself, you can do that. If you want other people to run an operator for you, you can do that. And so you have like a lot of flexibility here, depending on what your use case is, right? Maybe a use case is just like, hey, I want to have like a trap that kind of acts as like a little trading bot, and I just want to run it myself, right? And if I ever want to change the logic, I'll just change my solidity trap, right? That's all I need to change, and I can just reapply if I want to update the logic at any point in time. I want to use a different pool to trade on, or I want to look at something else, right? You can do that. So it's really meant to be a really flexible system that can be used for anybody. Like anybody can use it however they want to use it. If like having a bigger decentralized set is really important to you, then you would want to configure your trap to be that way. And this is like really important because there's just a large diversity of people out in the world, right? Like some people may say, hey, I actually have a protocol that I want to use this trap with, and I want to have a decentralized set because I want to have like increased security for this piece of infrastructure. Then you can have other people opt in. You can run multiple nodes. You have just tons and tons of flexibility there. For the ZK piece, we haven't touched too much on that. I almost feel the ZK piece is probably like a whole other workshop within itself. But I would say you can look at the dev docs, and we do touch on that, and you can like look at that stuff yourself. There's like ZK claim and dispute. Dispute should really not be something you ever need to use, but ZK claim is a CLI command that you guys could look at in the dev docs.
if you're deploying the trap yourself, then like that's all up to you. What kind of due diligence you want to do. If I'm running my own like little pet project, and I can deploy whatever. If I'm deploying a trap for a big protocol and it's maybe acting as a security mechanism for millions of dollars, then I probably maybe I'll pay for that to have it audited. So you can have any level from 0 to 100. It's really up to you.
I guess, Bubba, do you want to go into the consensus mechanism? Because I've seen a couple of questions of that.
Yeah, I can touch on consensus. So basically, the thing to understand is your node set that is running your trap is like your validator set. You can think of it like that, right? The operators that are running your trap are all of these different nodes that can talk to each other about what their result is, because they run the trap every single block, so they get a new result. They get a new result saying, hey, for this trap hash, or for this block hash, I was running this trap, and this was the result I got. It was should respond true or should respond false. What the node will do when it creates that calculation itself is it's going to gossip to the other nodes under that trap what its result is. We do something kind of sophisticated called BLS signature aggregation, where the operator actually signs the calculated result of the trap and then sends it out to somebody. And the node receiving that gossip will then aggregate that signature with its own signature if it got the same result. So that's almost like coming to consensus, right? So you can think of like this gossiping happening allows for each node to understand, did you get what I got? Did you get what I got? Did we all come to consensus? If there is a 2/3 majority consensus, then this allows for the operator to recognize, oh, I have a supermajority consensus on my result. If the result is should respond as false, clearly there's no action to take, right? It's just like, yep, we got consensus that there isn't anything to do. There's no action to take place. But if should respond is true, then that tells every operator that came to consensus, hey, I can push the aggregated signatures on chain with the result, and the Solidity contracts, the smart contracts of Drosera, will verify those signatures and make sure, yep, it looks like a supermajority was a consensus was reached and should respond is true. So this will go and automatically trigger the response function that is set in that Drosera.toml for that trap. So that is kind of like the flow. They're all kind of coming to consensus, and then they try to like push a message on chain to then trigger that response function.
Okay, can users or agents opt out later, and what are the implications? So just as I opted in, I running the opt-in command. You can also run the opt-out command. We didn't touch on that one, but you can. And I won't say too much about it at the moment, but once things in mainnet, then there will actually be like a financial reasons that you will opt in or opt out from traps. So that's a whole nother aspect of things to come later. But on testnet, you can just feel free to opt in if you want or opt out if you want. You're the operator, you have control over which traps you decide to run.
And you can kick people too. That is also another command that, say you are running a private trap and you've invited two of your friends who are also running operators, and you don't like one of them for some reason, you can kick them from your trap. So in the future, if you're running a public trap and you have public operators and you find that one is just not, say they're not up, they're just always down, and they said they're going to opt in and they're just never running, you can kick them from your trap as well. So keep that in mind.
So I guess, technically if you're one of these people that you really hate the red blocks, even if an operator is actually running your trap totally fine and honestly, then if you don't like red blocks in your trap, technically you could kick them and only keep operators that have green blocks, which means, they're kind of an operator running at a little higher standard maybe, like because they have their ports and their whole configuration set up properly to allow the liveness data queries. So technically you have control for that.
Who is the first between kick operators and opt out? So opting out just means that an operator who's opted in can opt out. So I can't necessarily opt someone out of a trap, but me as the admin of my trap, I can kick them. So if you're the admin and say you're not running any operators, you're the admin of the trap, you're the creator, and you have operators that have opted in and say you don't want one of them in there, you can kick them. But it's different than opting out, where opting out is more of a command for an operator who has already opted into a trap. So that's the key difference between what kicking operators is and opting out. You're just, as an admin, I can kick them. As an operator, I can opt out of a trap.
Right.
Droic tokenomics. We briefly talked about it yesterday, but there will be staking in the future. And so what staking does is it allows someone who is holding the Dro token to then earn protocol rewards from all of these other people that are creating and updating their traps. So in the future, when you create a trap, you'll spend some Dro to create the trap. And when you want to update your trap, spend some Dro to update that trap. And so all of that goes into a big protocol pool. And if you're staking, you'll receive a portion of those fees. So that's kind of a super, super high level. I know it doesn't go deep into tokenomics, but at a very, very high level, this is kind of where it's starting. We have some other ideas in the future on how we could use Dro as more of a gas token. So instead of with some of the new EIPs, you can kind of get away with using ERC20 tokens as gas. So instead of having to have a gas token like ETH, we could theoretically use Dro as a gas token. So you can pay gas fees with Dro itself. So it's another kind of smaller way that we can introduce the token for the token economics. But we'll go into that more in the future once we get onto mainnet. And yeah, the call will be recorded. It is being recorded, and we'll put it up on YouTube as well. If you guys haven't seen, there are some other videos on YouTube, some walkthroughs that both myself and Jake have gone through. And so if you have any questions or anything, or you want to see more of a visual aid for all of this, go to our YouTube channel and you can watch some of the video walkthroughs. I know I've done one that goes through basically 0 to 100 using our create Drosera app extension that kind of builds an entire Drosera front end and operator. Whole walkthrough to do from 0 to 100. And I know Jake has gone through a lot of the operator commands as well to get you more familiar with how operators work and what those commands actually do.
Yep, I put the YouTube link in the chat here for everyone.
And again, if you guys haven't seen the examples repo, it's a great place to kind of get initial ideas of how, on the security side, more so than necessarily the automation side, how security can be used with Drosera. We go through and mock out a lot of these old exploits that have happened on different chains and have shown how Drosera, or how you could have made traps to look for some of these exploits. Maybe not to stop all of them, because some of them are single block exploits, but how you can mitigate risks. So a lot of times we talk about there needs to be some type of response action. So say your liquidity pool is being drained. We could obviously pause that so it can't be drained anymore, but a lot of the actions that have been taken have taken hours for all of these people to get together to do something to stop it. Where with Drosera, you can automate that entire process and stop or pause or move funds immediately after you find something has happened. So it does mitigate that entire risk of losing money, because it takes a long time, especially as a dev. Most of these attacks happen at like 3 a.m. for us. And so trying to wrangle up, 3 or 4 multi-sig signers to sign a transaction to stop or pause or move funds is not ideal. And so with Drosera, you can automate this. You can watch for movements of liquidity pools or other malicious activity, and then respond quickly within a couple blocks instead of a couple hours. Yeah, so that's a good question. So how the workshops are really going to work is, we had the intro yesterday that kind of goes high level, more explaining the entire protocol and the system and how things work, what the files look like. Today, we kind of walk through just basically applying your first trap. We've made it for you. We've done everything for you, but it's really just for you guys to get used to doing these applies and running these commands. The one tomorrow will be very similar, but we'll start changing some things in the Drosera.toml, so you'll get used to changing the path that you're pointing to, the response contract itself that lives on chain, and some other things. And then the final one will be changing some solidity code. So being able to go through, feel comfortable changing solidity, compiling that solidity, doing some of the changes in the TOML again, and then ending up sending your Discord handle within that solidity code. So we can capture all of you guys that are actually working, and then deploying these traps. We'll get your Discord handles, and then give everybody that completed it a role, saying that they've done the workshop.
Yeah, so definitely to reiterate, definitely follow along with the workshops. Actually go and do them yourself, because there's a Discord role at the end of the tunnel here. So
yes,
and
everybody
great
wants a
place
Discord
to
role.
start.
So yeah, so go do that.
And get yourself prepared in the best possible position to get right into TryTrapMe when that gets launched not too far down the road, which that's going to be another level up, more advanced from what we're starting the workshops, to get people familiar with the basics and how to get going. And then TryTrapMe is going to kick things up a lot more serious. Maybe there'll be a leaderboard. Who knows? And things are looking good. All right.
Why do we see a Venus flytrap in Drosera? So a lot of people, for anybody that doesn't know where the name came from, a Drosera is basically a carnivorous plant. You've seen these plants that have these little, almost like beads of sap that kind of attract bugs, brings the bugs in and takes them. A lot of people, even though they're not necessarily the same thing, associate Venus flytraps with carnivorous plants, and so it's kind of a cooler image to show a Venus flytrap than necessarily an actual Drosera plant, because a Drosera plant is a little bit more boring than what a Venus flytrap looks like, but it's kind of conveying the same thing.
I'm seeing one picture here about an opt-out error. Okay, yeah, I've seen this one posted a couple times before. I opted out one time and I got this error when I tried to opt out, or tried to opt in after waiting for 2 days. Why is that? Duration, not
So the opt-out, what we do here is, in the future, we don't want operators opting in, opting out, opting back in again, to kind of hinder the actual trap itself. And so we do have a time period that you can opt into something and then opt out to opt back into it again. We are playing with the configuration of what that time period is, just so it's fair to everyone. I think we'll probably drop it down some in testnet, and I believe we did, but I'll have to double check on what that time period actually is. But that's what that means. That error basically means, for testing, I would just suggest making another trap for right now to opt back in. But theoretically, long term, you shouldn't be opting in, opting out, opting in, opting out. So if you opt into something, you can opt out of it, but there is a time period that you can opt back into it. We should probably bring that down to a couple blocks, which I believe we did, but I'll have to double check.
All right, cool. Any
Yeah, so I
final
think that's everything.
Yeah.
I don't see any more questions. Give it one more minute if anybody has anything else.
Last call.
But again, feel free to run through everything. If you do have questions, we'll be here tomorrow and we'll be here Friday as well. So feel free to make some questions for those days as well. That is a good one. How or when can we use hydration streams in testnet? So we have not created a faucet for the Dro token in testnet yet. We probably will. So you guys can start testing out the hydration streams. There really is no benefit to them yet because the hydration streams don't necessarily do anything because Dro is not worth anything. But I believe coming up we'll probably make a faucet for the Dro testnet token so that you guys can test out the hydration streams. But as of right now, like I said before, there is no fee. We have the fee set to 0 for applying or for creation and updates. But in the future, we will have some type of Dro fee to do the applies for creates and updates.
All right, cool. I think that's a good question to round out the workshop here.
Cool.
All right. Well,
I appreciate everybody from coming.
Yep. Thanks everyone for coming. Stay tuned and keep up the work for that Drosera roll coming at the end of this. It's got to be on chain, so you got to actually run the code and deploy it and deploy the trap yourself. Yeah. When we'll get this recording posted on our YouTube, and we'll let you know. And thanks everyone.
Cool. See you guys.
All right. Have a good one.